On the first day of school, I asked you to fill out a survey. One of the questions asked which students were taking AP Psychology and AP Biology this year. Here are the results. Out of 60 of Ms. Hammond's AP Statistics students, 9 are taking both AP Biology and AP Psychology, 10 are taking only AP Biology, 15 are taking only AP Psychology. Let's organize this data with a Venn diagram. This rectangle represents the AP Statistics students, and we call this the sample space. This circle represents those taking AP Biology. This circle represents those taking AP Psychology. This portion of the circle is AP Biology only. That's 10 students. This portion of the circle represents those taking AP Psychology only. That was 15 students. This middle part is the number of students that are taking both. That is 9 students. So 10 plus 9 is 19. 19 plus 15 is 34. Since there were 60 students in our population, that leaves 26 unaccounted for. This 26 goes outside of the two circles. So we want to find the probability of selecting one student who is taking AP Bio. These are all the students who are taking AP Bio. So out of 60 students, 19 of them are in Bio. Even though this fraction can't be simplified, we want to be aware that from now on we are not simplifying our fractions. So 19/60ths would be the final answer, or you can convert it to a decimal. Now we're interested in finding the probability of choosing a student that is not taking AP Bio. This is called the complement to AP Bio. The complement is the probability of an event not occurring. The formula looks like this. The notation has a little c next to the event. This represents complement, and it's 1 minus the probability of A actually occurring. So in our example, we're looking for the probability of not AP Bio, which we write as the probability of AP Bio with the C. This is the same as 1 minus the probability of AP Bio. We saw that the probability of AP Bio was 19/60ths, so the answer is going to be 41/60ths. If you look at our picture, the highlighted section are all the sections that are not AP Bio. So that's 15 plus 26 for a total of 41. Now we want to find the probability of someone being in AP Bio and AP Psych. The key word here is and. This is called the intersection, when two events occur on a single performance of the experiment. And the key word is and. The notation for this is an upside down U. So this is where students are taking both AP Bio and AP Psych. This is the intersection. So the probability of randomly selecting a student in both classes is going to be 9 out of 60. Again, we are not simplifying our fractions. Now we want to find the probability of getting an AP Bio or an AP Psych student. The key word here is or. If either event A or event B happen on a single performance of an experiment, we call this the union. The notation for this is a U. Makes sense, U for union. So this is what happens when we unite these two events. Notice that when we unite the two events for the union, the intersection gets counted twice. So our formula for finding the union is the probability of A plus the probability of B, so we're combining the two events, but we're subtracting an intersection because the intersection gets counted twice. So this is what the union looks like when we put the two circles together. We have the probability of Bio plus the probability of Psych minus one intersection. So we have 19/60ths plus 24/60ths minus an intersection at 9/60ths for a total of 34/60ths. One of the other questions yielded the following results. Out of 60 of Ms. Hammond's AP Statistics students, 24 students are taking AP Psych only, 5 students are taking AP Calculus AB only, none are taking both. Let's make a Venn diagram. Here's our sample space. We have AP Psych, 24 students, AP Calc AB, 5 students, 31 left over. Adding all the numbers together, we have a total of 60 students. Since these two events can't happen at the same time, since there are no students who are taking both AP Psych and AP Calc AB, The two circles do not overlap. These two events are said to be mutually exclusive. Another name for this is called disjoint. So mutually exclusive events, or disjoint events, are when two events that cannot occur simultaneously. So what is the probability of randomly selecting a student who is taking AP Psych? Well, I shaded in the area that is AP Psych, and we can see that is going to be 24/60ths. We are not simplifying this fraction. What is the probability of randomly selecting a student who is not taking AP Psych? So we're looking for the complement to AP Psych, which is 1 minus the probability of AP Psych. So we saw 24 out of 60 are taking AP Psych, so 36 are not taking AP Psych. This is what our picture looks like. The shaded area represents those who are not taking AP Psych. So if we add that up, we have 31 plus 5, so 36 are outside the AP Psych circle. Find the probability of randomly selecting a student being in both AP Psych and AP Calc AB. AP Psych and AP Calc AB is the intersection. The keyword is and. Where is the intersection? There is none, so the answer would be 0. Find the probability of randomly selecting a student being in both AP Psych or AP Calc AB. Or is the keyword that represents a union. Here's our formula for a union. Probability of Psych plus probability of Calc minus the intersection, since it's counted twice. In this case, there is no intersection, so that value would be 0. The answer is 29/60ths. So the union is 24 plus the 5 is the 29. My last example is that I survey in the beginning of the year also produced these results. Out of 60 of my AP students, 39 have been to Disney World, 23 have been to Disneyland, and 10 have been to both. Notice that neither of these statements include the word only. So here's our sample space. Here's the number that have been to Disneyland. Here's the number that have been to Disney World. Since 10 have been to both, we know that these two events must intersect. But when we find the union of these two events, that gives us a total of 72 students. This doesn't make sense since I only surveyed 60. Again, since we put these two events together, the intersection in the middle got counted twice. So the actual Venn diagram looks like this. 39 minus 10, that's 29. 23 minus 10, that's 13. Which means that since I had 60 students in my population, that there's 8 left over who haven't been to either. So take a few moments and see if you can do the following questions. When you're done, come back here and check the answers. Please make a note of any of the questions that you got incorrect and ask Ms. Hammond next class.